Hello everyone, welcome again to Dr. Tom. Guys, as you are aware that the discussions are going on immunology and it is a lecture third or rather part third of lecture 1. As I discussed in the last class that it is the most important lecture and yes, it is the most important lecture, right? In the entire immunology, because what we are going to understand today is the innate and acquired bridge. In the last session, if you can recall, we were discussing about the innate immunity, right? And we have reached to the cellular barrier. That was a very basic lecture, right? And of course, this is also a basic lecture, but it is a most important lecture for the entire immunology. So that's why I request you to please at least go through this lecture to understand the immunology for future as well. In the last class, what was the discussion was going on? Let me coming to the content or the PPT rather. Yes, so here we are. So guys, what was the discussion which was going in the last class or in the last session? Wasn't that do it is like that first innate immunity prevent us or then acquired come into the play, or how the things actually works? Is it the innate which activate first or then it is a acquired which activate first? And what is the funda? This is we have to understand. Let me give you a scenario, right? Suppose let's compare our body with a system. So say we yes, of course we have a body. A pathogen try to enters in the body, right? I'm starting the scenario. So actually the lecture is starting from here. It's 1 minute 46 second almost. So make sure the lecture is starting from this point. Suppose a pathogen want to enter my body. Now what I'll offer? My body first offer a resistance to that bacteria or to the pathogen as a skin, right? So my skin present this skin, my body present this skin in front of the pathogen. If pathogen is able to cross the skin, if anyhow say a pathogen enters through the opening, so that's how the first line of barrier breaks, right? Okay, fine. Coming to the second line of barrier, which is called as body secretion. Say if the pathogen enters to the eye or the pathogen enters to the mouth, fine. I have saliva in my mouth, I have enzymes over there on my body's surface, I have some secretions. All a bacteria basically, a pathogen overcome all these barriers. A bacteria or a pathogen now enters into the tissue, now enters into the circulation. So say now what the third you know uh, barrier which should activate according to what we have studied. So it should be innate barrier. Basically it should be a cellular barrier. And yes, now cellular barrier comes into the play. So we have discussed that we have the so many cells of immunity. We were talking in the last class about the WBC classification. We have discussed that we have granulocytes, we have agranulocytes. Even in the under the granulocytes, we have neutrophil, we have basophil, we have eosinophil. Then in the agranulocytes, we have monocytes and lymphocytes. Monocytes are something which transform to form macrophages, and lymphocytes are something which are of two type, T and B lymphocytes. What is their function? We are not supposed to understand them today, but yes, we will talk them about them in very brief. Right? This is the all. The lecture is actually going to about that how an innate and acquired are linked together. Right? So let me do one thing. Let me take off from my video so that we can have a good space, and from where we are going to start the discussion that a pathogen enters into the cell. Then what happens after that? A pathogen enters into the body, into the cell, and what happens to that? And we can compare the whole scenario with the city, right? Say we are living in Delhi. So say in our city some not terrorist, I should not say terrorist, we have a very good soldiers. They never allow the terrorists to come in Delhi or in our city, in our country, right? But say some bad elements try to enter into the cell, some thief enters into our street. So we will compare the whole discussion with that scenario that the thief is entered into the street, and similarly the pathogen is entered into the body. So let's start now the discussion, and let me take my video off. Fine. Let's now consider that a pathogen enters into the body. Now of course the discussion is little slow. I'll use I'm not going to be very fast, but yes, this is very important, and please, it's a request, Guys, if you're writing or if you're doing anything, please leave it. Just listen to me what I'm saying. Say a pathogen is there which want to enter the cell. Let's say this is a pathogen, right? That's a pathogen. Okay, the pathogen is beautiful eyes. So we can decorate the pathogen, of course, we would decorate it. So the pathogen has a good eyebrows and pathogen is smiling. Why the pathogen is smiling? Actually, the pathogen is smiling because pathogen now has entered into the cell. We are considering this. Now, what after that? Say the first line of barrier goes away. I mean to say the pathogen overcome the first line of barrier, pathogen overcome the second line of barrier. Now, it is a time of immune cells which has to take care of this pathogen. This is now the job of immune cells. Now, what all the kind of cells we have into the body, right? As I told you earlier that we have different cells, but I will talk these cells separately and one by one in different lectures in detail, right? What is my purpose now? To create a big picture. Now listen to me very carefully. This pathogen can be attacked by, say, neutrophil. As I told you that neutrophils are the most abundant cells. Two things can happen. I would go with the second aspect, but let me make a neutrophil here. So say a neutrophil is there, right? This is a very happy pathogen, and let's say this pathogen can be attacked by, we have this cell which is neutrophil, right? So this is a neutrophil and let me label it as neutrophil. Now listen to me very carefully, please. This is a neutrophil. We are not talking about the characteristic neutrophil, hence do not go with that nucleus that I haven't drawn the multi-lobe nucleus, so don't worry about that. Now this is the nucleus. Every nucleated cell in our body, please, this is very important, guys. Every nucleated cell in our body, and I know that I haven't uh, have the discussion of what are MHCs and so, but please, for now, just recall them that every nucleated cell on the surface shows a one kind of protein, what we call as MHC1 protein. So yes, this is something called as MHC1 protein. So let me label it as, and every nucleated means every nucleated, doesn't mean that it is a immune cell or it is a normal cell or it is not an immune cell. So every cell shows this, that is MHC molecule. Now what is this MHC1? It's exactly MHC. What is the meaning of MHC? Let me write the full forms in another page because I use this slide. So let me write the full form for you. MHC stand for mega histo compatibility complex. This is something important, right? 1. If it is MHC1. Similarly, we have MHC2, but please, this is something very important. I'm telling you, MHC1, it is presented by every nucleated cell. I'm using the word nucleated, please. Every nucleated cell in the body. This is the first thing you have to learn, right? Coming to the second aspect, and let me coming to the discussion back so that we can discuss. So it can be done. I mean to say this neutrophil can eat this pathogen, and the neutrophil just kill this pathogen, and the story is finished here only. Nothing will happen further. This is like that. Neutrophil comes, eat the pathogen, and fine. Okay, nothing. Okay, neutrophil is a phagocytic cell. Let me write it here about it as well. Neutrophil is a phagocytic cell. I hope that you are not having any background noise from my background because it's the time of elections in our city. So may possible that you can have that sound. So I mean to say, advertisement is there. So neutrophil is a phagocytic cell. So what is a phagocytic cell? Phagocytic is a cell which can eat a pathogen. So basically, phagocyte means eat pathogen, right? I hope I made myself clear. If neutrophil did so, suppose if this pathogen comes in the contact with neutrophil, then this neutrophil just eat itself, and the chapter of this pathogen will close. Nothing happen further. But of course, we would not talking about that pathway, right? For now, we are not just taking neutrophil into account. right? That is the one thing you have to understand, that if neutrophil eats a pathogenic cell, that the story is finished over there. The pathogen will kill definitely. Now what we want to learn is another story. So for that I would like to go to another page, because I don't think so I can cover it here. So this is the first story, right? Now let's make another pathogen for our understanding purpose. So say this is a pathogen. Just please guys, I'm saying please, it's something which is very very important. So say this is a happy pathogen. This pathogen just enter into the cell, right? So this is the pathogen, and now in that situation we are considering that this pathogen is encountered by one of other immune cell, that is called as macrophage. So now the discussion is going to be started. So say this is the macrophage, right? So let's now draw a macrophage. Okay, fine. So guys, can you see this macrophage? Right? Can you see this? This macrophage is actually eating this cell. Now let me write a few words about macrophage as well, but what you have to understand is that this pathogen comes and this pathogen is now captured by macrophage. It is actually a macrophage. Let me put a M so that you can realize it later. Yes, it is a macrophage. Now here let's stop for a minute and let's talk about macrophage. Don't worry, we have 2 or 3 lectures on macrophage separately. It's just a basic discussion. Macrophage is also a phagocytic cell. Right? Along with the phagocytic cell, it is an antigen presenting cell. Now, the question is that what is an antigen presenting cell? What is the function of antigen presenting cell? So we'll come to in a minute, and we also need to understand that macrophage shows MHC2. Macrophage and not macrophage, actually all antigen presenting cell. In short, we set them APCs. In short, these antigen presenting cells are called as APC. So let me write it like that. All APC shows MHC2. That means all APC means antigen presenting cell, shows MHC2. So it is a MHC2 molecule is expressed by all the kind of antigen presenting cell. Please, this is something which you must know. So what cells are antigen presenting cells actually? So we have, say, macrophage are antigen presenting cells, we have dendritic cells which are antigen presenting cell, we have B cells which are antigen presenting cells. Don't worry, we'll keep talking about them, but now for our discussion you have to understand that macrophage are one of the antigen presenting cell. Right? What is the meaning of antigen presenting cell? We'll just clear it out in a minute, but let's come to the macrophage. So does it have MHC1 as well? Yes, why not? It is a nucleated cell, so it has MHC1 as well. And here I am not able to select the pen, but yes, I can. So say this is MHC1. This is MHC1. Say this is MHC1, but we are not drawing it around because our work is here with the MHC2. And say it is a MHC2. Let's make it like that. So it is a MHC2. Please, this is very important, guys. You have to understand that macrophage is a antigen presenting cell, and every antigen presenting cell has a molecule. It is a proteinaceous molecule actually called as MHC2. Of course, because say for the exams like CSIR-NET, for Indian exams, right, it is important that you should know that how the MHC processing takes place. So don't worry, we will upload the lectures of them as well. If you want, you can tell me about it as well, right? That what kind of lecture you want or something like that. Okay, anyway, so this is something, it is MHC2. MHC2 is a protein, and always remember, as I told you that in case of neutrophil, when a neutrophil encounter a pathogen, what neutrophil do? Neutrophil eats that pathogen and finish up. Nothing, no story remains. But this macrophage is intelligent. The macrophage think like that. Okay. I have captured a pathogen. I have phagocytized it. Now let me put the pieces of pathogen. Let me put it on my MHC molecule, and I have to show them to each and every immune cell. It is same like that. Okay, let me come back for a minute to talk to you. So wait, here I am. Yes. So it is similar like that, guys. Wait. So what is important to note that suppose in our street a thief comes. Now suppose I capture that thief. I capture a thief. And now I'll show that thief to everyone, at least. Or what can I do? I can go to the police station. I can show the thief to the police and said, look at the police. This is the thief. That's how the thief looks like. What the police will do? The police recognize that. The policemen recognize that thief, and if anyone thief like person comes again in future, the police will more active, because now thief have already recognized by the police. Similarly, what APCs do, what macrophages do, macrophage engulf a cell, eat the cell, that means phagocyte it. After that, break the pathogen into pieces. Now express that pathogenic pieces, means antigenic pieces, on MHC2 molecules. What is MHC2 molecules? MHC2, with the help of MHC2 molecules, this macrophage present these pathogens, that means express these pathogens to each and every cell of immune cells, at least immune cells, not each and every cells, to immune cells. This is something which is important, right? So that would be the other part of this story, that now the pathogen is captured by the macrophage hold the pieces of pathogen on the MHC2, and it continuously running toward nodes, lymph nodes. What are lymph nodes? Lymph nodes are the storehouse of immune cells. So similarly, say we have captured a thief, we just run toward we continue run toward the police station, because what is a police station? Police station is the hub of the policeman, right? So that is what it is going to be. Now this macrophage capture the pathogen. This macrophage running toward the nodes, lymph nodes, because in the lymph nodes we have immune cells, we have T cells over there, we have B cells over there, and other cells as well. Let's now talk about that story in a minute, right? Yes, so here we are on the right page. As soon as this macrophage engulfs the pathogen, the macrophage shows the pathogen on the MHC2 molecule. So say these are the pathogenic pieces, or pathogenic means antigenic pieces. So these are antigenic pieces. This is something which is very important, right? Okay, you have to remember MHC1 molecule never shows a pathogen. It is a MHC2 only. Now, as soon as, and can you realize that this macrophage is a cell of innate immune system? Can you realize that the macrophage is a cell of innate immune system? So yes, the pathogen is taken care by the innate immune arm. But look what is going to happen now. So what happened? This macrophage now, yes, this macrophage is continuously running toward the lymph node, as well as the macrophage is releasing a chemical, right? And the chemical name is IL-12. So it is IL-12. What is IL-12 meaning? IL stand for interleukin 12. So IL stand for, let me write it here, if you need these PPTs, you can let me know in the comment box. I'll provide you these PPTs in say in a Telegram group probably. So interleukin 12. So IL stand for interleukin. What are interleukin? Interleukins are the chemicals. Don't worry, we'll talk about these interleukins in detail. Now coming back to another discussion. This is now something very important. This is a cell of innate immune system. We have other cells of innate immune system. We'll talk about them in a minute. Actually, what happens, if you can recall, in the last class we have discussed that we have cells of acquired immune system as well. That's what we call as the T cells and B cells. So when a T cell is formed, or when a T cell is produced, actually it produced in the bone marrow, right? At that time the T cell is completely unaware about the function of its, that what is my function. So what exactly is going to happen, that we have a T cell as well, but when a T cell is produced in the bone marrow, T cell is not aware that what is the function of T cell in the body. So that kind of T cell is called as naive T cell, or we also call it as T0 cell. So let's make it. So this is what we have as a T0 cell. So T0 cells are what kind of cell it is? It is actually just a newly formed T cell in the bone marrow. So every newly formed T cell in the bone marrow is called as T0 cell, and T0 means naive T cell. What is the meaning of a naive? The one which does not know the function of its in the world. In the world means in the body, right? So now this T0 cell, as soon as it received a signal from macrophage. That is, a signal is basically in the form of chemical, and what is the chemical? IL-12. Now this T0 cell has a receptor for IL-12, right? This IL-12 activate this T0 cell, and always remember that this T0 cell is now going to transform into T helper 1 cell. It is a T1 cell, right? So this is very important. You need to understand that as soon as this T0 cell is triggered by IL-12, this T0 cell is transformed into T helper 1 cell, right? So now this become, say, let me make it here, that this cell become T helper 1, right? So this is what exactly happened. So what exactly happened is that this T0 cell is transformed into this T helper 1 cell when this T0 cell is activated by this IL-12, right? So I hope this makes sense. Now, what is the function of these T1 cell? You may ask, what is the function of this T1 cell? Actually, this T1 cell now releases two kind of chemicals. It releases many, but the one which we need is this. So it releases one of the chemical which activate macrophage, and the name of the chemical is gamma interferon. So it releases gamma interferon. This is interferon. So this gamma interferon acts on macrophage. Macrophage has again receptor for this gamma interferon. So what is exactly happening? Listen to me very carefully, please. This macrophage is activating this T0 cell. This T0 cell is actually a naive cell, right? This naive cell is just, formed inside the bone marrow and don't know the function. Don't worry, it is not suffering from the jaundice. It's just a one-legged thing, right? This T0 cell transforms itself into the T1 cell. This T1 cell now release gamma interferon. This gamma interferon is again acts on macrophage and activate macrophage and said that macrophage, you please eat and eat and eat and more pathogen. It is similar like that. We go to the police and we ask them, hey, look, police, this is the thief. Police give us the license. Okay, Govind, or anyone who is going, who just shows the thief to the police. The policeman said, hey man, take the license, now you can kill more thieves. It is similar like that. So this is called as, means this macrophage, look at this pathway. This macrophage activate T0 cell, this T0 cells activate T helper 1 cell, this T helper 1 cell again activate macrophage. This pathway is called as, what it's called as, gamma interferon interleukin axis, or interleukin gamma interferon axis. So it is an interleukin 2 because 12, because which activate T0 into T1, and this T1 then releasing the gamma interferon. So this is why it is also called as interleukin gamma interferon axis. Gamma interferon axis. What pathway? This entire pathway, right? So let me draw it with a white or a color so that you guys can realize what I'm trying to say. So this pathway, this entire pathway, right? This pathway where I'm coloring. So this complete pathway is called as gamma interleukin interferon axis pathway. What this pathway is explaining, that macrophage is activating T0 cell. T0 cell then transforming into T helper 1 cell. T helper 1 cell then activating again macrophage and said that, okay, macrophage, kill more and more pathogen. Always remember, these T cells are the cells of acquired immune system. That means adaptive immune system. The one which we get during our lifetime. That immune system is called as adaptive or acquired. This macrophage is a cell of innate immune system. So innate immune system, you can see, now you can realize that activating acquired immune system in turn activating what? Innate immune system. The story is not finished yet. We have a lot to discuss. This T helper 1 cell releases one more chemical, and this is called as IL-2. So say this releases one more chemical. This is called as IL-2. IL-2 stands for interleukin 2. Now this IL-2 has two kind of actions. It has autocrine action. Autocrine action means it acts on self. So this IL-2, which is releasing by the T helper 1, is acting upon it only. First of all, it is acting upon it as well. So not only this IL-2 actually acting upon this T helper 1 cell, and this T helper 1 cell again activating more macrophage. So this is called as autocrine function. So we can say that auto activation of T helper 1 cell by itself. It is releasing IL-2 activating itself, IL-2 doing another job as well. So what is that job? Let me now discuss. This IL-2 also activate one more cell, and this one more cell is called as cytotoxic T cells. So we have varieties of T cells actually. Trust me, yes, we have varieties of T cells. And what these varieties of T cells we are talking about? So yes, this IL-2 also activate one more T cell, and that T cell is called as, actually I'm making this T cell here only. So this T cell is called as cytotoxic T cell. So let me make that cytotoxic T cell for you. So this is what is happening. What we were talking about, that it is a IL-2 which activate also this cytotoxic T cells. So this IL-2 actually activate this cell as well. This is a cytotoxic T cell. So let me write it here that it is T cytotoxic, right? This is important. So this is T cytotoxic, means it is a one of the T cells. Once this T cell activate, what this T cell do? This T cells directly kills the cell. So this is a pathogenic cell. Say this is a pathogenic cell. This is a pathogenic. My marker is not working here well, but I'm sure that you can see. So this this cytotoxic T cell is what exactly it is doing? It is killing a pathogenic cell directly. How it is killing? Say this T cells release some enzymes, say ghrelin enzymes, perforin kind of things. So we'll talk about more that how do they function. But right now you have to understand that once T1 T helper 1 cell release IL-2, this IL-2 acts on cytotoxic T cell. This cytotoxic T cells kill another pathogen directly. That is a one fate. That is a one fate. Coming to the another fate. Actually, we have other cells of innate arm as well. Let me now talk about one more cell that is called as basophil cell, or say mast cell, right? So look at here that it is a mast cell. Say it is a mast cell, and how I remember mast cell is that it is wearing a mask. We just overcome the pandemic of COVID, so I'm sure that you all are aware about the COVID. So it is a mask, right, of the COVID. So that is why it is a mast cell. Not like that because it is wearing a mask, so it is a mast cell. No, it is a basophil. Actually, it is a mast cell. It is also a cell of innate arm cell. So let me write it here that it is a basophil, or it's a mast cell, right? Mast cell. Actually, this mast cell also releases, upon activation, this also releases a one more chemical, and the chemical name is called as IL-4. This is called as IL-4. So let me choose this. So this mast cell actually releases IL-4. So this IL-4, this is IL-4. Actually, this T helper cell, actually this T helper, T0 cell, not helper, T knife cell, this is also called as knife, the one which is not aware about the function, has a receptor for IL-4 as well. So things are taking simultaneously, that the T0 cell can be activated by IL-2, or the T0 cell can be activated by IL-4. But once it is activated by IL-12, the T0 cell transforms itself into the T1 cell. But if the T0 cell is activated by or acted upon by what we call as IL-4, then this T0 cell transform itself into T helper 2 cell. So we have here this T0 cell transform into another kind of T cell, what we call as T helper 2 cell. So right now we have the T helper 2 cell. So let's now make a T helper 2 cell. So here we have this T helper 2 cell. So what exactly happened? IL-4 acts on T0 cell. This T0 cell transform itself into T helper 2 cell. This is again a very important thing. This T helper 2 cell, what exactly do? This T helper 2 cell helps to activate another cell called as B cell. Yes, this is a B cell. So say it is a B cell. It has a big belly. So let me draw it like that. That it has a big belly. It is a B cell. So T cell also releases chemicals what we call as IL-4 and IL-5. So yes, this T cell, T helper 2 cell also releases IL-4 and IL-5. When we talk about antibodies in detail, so over that time we'll talk about class switching. So over that time we'll see that how these interleukin actually helps. But you can realize one thing, that if this T helper 2 cell is releasing this interleukin 4, then this interleukin 4 is also or not self, basically is also acting on T0 cell too. So the T0 cell receive IL-12 from macrophage and IL-4 from two sources, from mast cell and basophil, and from the T helper 2 cell itself. And this T helper 2 cells make more T helper 2 cell by activating T0 cell. I hope I made myself clear. Because this T helper 2 cell itself releasing IL-4, this IL-4 also act on the T0 cell, then the more number of T0 cell activate on the T2 pathway, on this T pathway, T2 helper side. Okay, this T2 helper side activate the B cell, and the B cell releases what we call as immunoglobulin, that means antibodies. That is antibodies, guys. This is antibodies. And now what are antibodies? Antibodies are nothing but immunoglobulin. I'm sure that you are understanding the session. So look at this, this is a very fascinating, and I always love this session. I always love this session because can you see that a pathogen is entered in the body. This pathogen crosses the barrier, that means the skin, second line of barrier, and inflammation, and so and so. Then it is captured by, if it is captured by neutrophil, the story finishes over there. Because neutrophil is not an antigen presenting cell. This is something which you must aware of, right? Neutrophil is not an antigen presenting cell. Because neutrophil is not an antigen presenting cell, the story finishes over there only. When it comes to the macrophage, macrophage engulf the pathogen, macrophage then break down the pathogen and shows the pieces of pathogen on its surface, right? And it activate other immune cells. How it activate, we have seen. So it is similar like that. We have captured the pathogen, captured the thief, captured the terrorist. We are going to the police department, or and we are telling them, hey, this is the thief we have. So similarly in our body, macrophage capturing the pathogen, activating the lymph node. In the lymph node we have varieties of immune cells. We have T cells and varieties of T cells. We have B cells also over there. So we activate T cells, T0 cell. When a T0 cell is produced, a T0 cell is produced as a naive T cell. Naive T cell is that cell which do not know the function of its in the world. So we have this as a T naive cell. Now what exactly happened, guys? This T naive cell can either transform into T helper 1 and can either transform into T helper 2 depending on what kind of interleukin it is acted upon by. If it is acted by interleukin 12 then transform T0 into 2 helper 1 arm, T helper 1 arm then releases IL-2. So we can remember it like that. IL-12 has 1 and 2. So it activates T0 into T1. So IL-1 means IL-12 means it has 1. So T helper 1 and 2 remain. Then this 2 is released by T helper 1. So this is important. T helper 1 then releases gamma interferon. This gamma interferon act on the macrophage and activate macrophage to eat more pathogen. So innate is activating acquired and acquired is activating innate. Then we can see the entire acquired pathway, that the T helper 1 activating cytotoxic T cells. If it is transformed into 2 helper 2, these 2 helper 2 cells are activating B cells, and B cells release immunoglobulin, means antibodies. Antibodies then take care of the pathogen as well. Now I have a question, guys. Do the innate and acquired are the two different, or the two one, or the one system? I'm sure what would be your answer? You may say that they are the two, but they are one. I mean to say, yes, of course, we know that the acquired immune system is that which we acquire in our life when we encounter the pathogen, whereas innate is something which we all the time have, right? Don't worry, in the future lectures you will realize that why acquired is a specific. I'm sure that you are now aware that why innate is known as specific, because innate, say, including a macrophage attack all the foreign pathogen, no matter is a bacteria, virus, or what. And if I talk about immunoglobulin or antibody, which is a defense mechanism of acquired, then antibody is specific toward a pathogen. Suppose if it is a bacteria, let me go back to the slide. Suppose if it is a bacteria, and for this bacteria we have this immunoglobulin, then this immunoglobulin will only act on this bacteria only. If a virus comes, then this immunoglobulin, even if it is present in the body, cannot help us. That is why it is a specific. Specific means it is specific for the bacteria. So that is a discussion. The last key takeaway you need to understand is that all nucleated cells present MHC1, and all antigen presenting cell present MHC2 as well as MHC1. Hope you got what do I mean by the innate and acquired bridge. And always remember, these are not the two I mean to say, yes, they are the different system in the body. The way they work a little different, but both things takes place simultaneously in the body. So it is not like that okay, very first time it is a innate which is only working, then only acquired comes. So no. Hope the discussion would be helpful. Now from the next class, I'll check out the syllabus, right? I'll see if all I have clear at least basics, and I'm sure now basics are clear of immunology, because if you are here on my platform, I'm sure that you have studied the basics, or even if not, the first two lectures help you a lot. From the next class, probably either we will start with neutrophils, or let's see if some more basics need to be covered. Thank you very much, guys, for this session.